Is same tree given the roots of two binary trees Q and A, or P and Q, write a function that checks if they are the same or not. Two binary trees are considered the same if they are structured identically and the nodes have the same value. So it's important to note that we have this tree node object. That's what P and Q are. So this seems pretty straightforward. We're gonna do if P is not equal to Q, P dot value dot val, and then we'll return false. It's the easy way to start it out. And then after we do that, we're gonna see this might, yeah, let's do this. Do the question mark syntax. And then we'll return is same tree, P dot left, Q dot left, and is same tree, P dot right, Q dot right. Again, just looking at the properties that we have defined here. So we got to think about edge cases. We kind of handle the null edge case with the question marks. We could actually simplify this. So basically, if the value at the node we're looking at are the same and the left tree is the same as the other left tree and the right tree the same as the other right tree. So we could run this as it is. Let's take a look. Okay, so the issue here is when we're hitting this null case, that they are equal because they're both null. So we'll keep that. We'll do an additional case here. Something like this. So if at least one of them has a value and they have the same value. And the theory is that we won't, if one of these are null or undefined, then when we get to this step, we should opt out because whatever value we have stored will not be equal to null or undefined. So we shouldn't have to worry about going down these is same trees. Cool. And we could kind of look through this. Constraints, not important. Okay, everything else seems unimportant, so we'll just submit it and see how we did. And we do get a, well, they do have null. I guess that makes sense because of how the tree probably prints itself. It's probably the left This is the root, this is the left, this is the right, which should be null. The left of 5, null, the right of 5 is 15. They're the same if they're structurally identical, and the nodes have the same values. Oh, so I said that it was true, but it should be false. I'm also concerned about the value 0, which is why I don't simplify this any more than it is. I'm thinking that the issue is the difference between null and undefined as a value. Let's do a console log of p.val and q.val. Actually, let's just simplify that. Or maybe I'm just not understanding how this outputs. So we do 10 and 10, that makes sense. 5 and 5 makes sense, but we never do, seems like we never do 15 and 15. Which in theory would be the next step. Like the right side of this P should be 15, the right side of this should be null. Let's do this. Do that. And then we'll change this to Q. We have a syntax error. We didn't put a period here. We lost it at some point. So, yeah, we have 10, 5, 15, and this is the right hand. This is, okay, so this is the right hand of that. And so 5 for both of them should be next. The left of the 5, the first one is null. I would have thought it would be bit 15. Undefined is null. I think that this should be 5 null 15, which it is. This one should be null null, that's correct. This one should be, go here, null 15, that makes sense. DSA roadmap. What are we talking about here? Roadmap SH. So I'm trying to figure out why it's not returning false. Let's just print P and Q. So from here, we're going to the left, which would be null, and from here we're going to the left, which would be null. Null null will give us true. But why aren't we going to the right? Why aren't we going to the right of 5? So confusing. You would think that it would be harder to get a true than a false here. But apparently that's not the case. Even this prefers to have null and null, but for whatever reason, well, because we're doing null dot left, null dot right. So when we hit this, we get false. We don't even do it. We should pop out of here with false. Which would mean we don't. And then we would end all of this with false. We'll do if not B and not Q, return true. And then if not B or not Q, return false. And then we can get rid of a lot of these question marks. Submit it. Okay. I tried to make things simpler, but they actually ended up making it more complicated. But we did hit the 0 milliseconds, so that's great. Let's look at what the other solutions had in mind. So they created an inner function here. They had a response or a result of true by default. Basically, tree P, tree Q. So they're just like iterating the tree, which is what we did. At the response, at the value result equals that. I'm kind of curious if if result. So we'll only do this line if we think it's still a good tree. They could have done this in one if. It's a minor optimization. They probably didn't need to do to return null. Or you could just do return, but you could just have like this, combine all of these into a single if. Really? It's interesting. What is this? So they did something similar. Depth first search. And what did they do? If not N, return F. Okay, it makes sense that this would be slower. But basically it's concatenating a bunch of Fs and seeing if there's both of these arrays end up being the same. If not, okay, so you're putting the val. They're basically like converting it to an array and seeing if the two arrays are the same. I feel like you could mess with this and give it an input that's not necessarily the same. Because you're just concatenating empty strings here. Like if you had a 10, or you had like 11 and a 110, I feel like you could mess with this and get a bad result. This one had similar ideas to us, so where they had some base cases. They did their own stack track. So rather than recursively calling a function, they did some stack tracking. It's a little complicated, but try to keep it simple with our solution.